Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 20 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3314. Construct the minimum bitwise array 1. So let's read the problem statement. You are given an array nums consisting of n prime integers. And what are prime integers? A prime number is a natural number greater than 1 with only two factors, 1 and itself, like 2, 3, 5, then 7, then 11, then 13, then 17, then 19, then 23. Clear? So you need to construct an array answer of length n such that for each index I, the bitwise OR of answer of I and answer of I plus 1. So here you have to select one value. So consecutive values you need to select. So sum of them, not sum, bitwise OR of them. It should be equal to the nums of I. That is answer of I or answer of I plus 1. It should be equal to nums of I. Additionally, you must minimize each value of answer of I in the resulting array. If it is not possible to find such a value for answer of I that satisfies the condition, then set answer of I value equal to minus 1. So this is what you need to do. So now let's understand this with an examples here. So first, if you see the constant, size is very small. Nums.length just from 1 to 100. And nums of I values also from 2 to 1000 only, and nums of I is a prime number. So here if you see this example number 1, so if you see this 2, so for this is 0 index, this is 1 index, this is 2 index, this is 3 index. So for I is equal to 0, as there is no value for answer of 0 that satisfies this answer of 0 or answer of 0 plus 1 equal to 2, so answer of 0 is equal to minus 1. So first you should know this OR. So in OR, let's say you have two values A and B, and then these two values, let's say both are 0, so your output is going to be 0. If any one value is 1, so your output is going to be 1 always. So this is your bitwise OR table. So now here, in case of 2, I have options. I can select 0 and 1. So I'm getting a 2? Tell me. No. Can I select 1 and 2? Let's see. Again I'm not getting 2, I'm getting 3. So no result is possible. So that is why I'm writing minus 1. Now if you see this 3, so in case of 3, if I write 0 and 1, I'm getting 1 only. No, answer is not possible. I need it equal to be 3. If I choose 1 and 2, now I'm getting value equal to 3. So 2 or 3 I'm doing here. Not 2 or 3, I'm doing 1 or 2. 1 or 2 I'm doing. 1 or 2 I'm doing. So I'm getting 3, which is equal to this. So we have to return the minimum. Minimum is 1. So that is why output is 1. For I is equal to 1, the smallest answer of 1 that satisfies the answer of 1 or answer of 1 plus 1 is 3 is equal to 3 is 1. So 1 here and here, this answer of 1 value is 1. So this is 1 plus 1, 2. So 1 or 2, it is equal to 3. So this is true, right? So because 1 or 1 plus 1 is 3. Clear? So this is value of answer of 0. Here I have to fill answer of 1 value. Here I have to fill answer of 2 value. Here I have to fill answer of 3. So don't get confused. So this is just indexing I'm doing. Now what is going to be value of answer of 1 value? We find out that it's going to be 1, because 1 and or if I do with 2, I'm getting 3. That is right. Now here same way for 5 you need to find out. So can I use 0 and 1? So I will not get 1. Can I use 1 and 2? I will not get equal to 5. Can I use 2 and 3? No. 2 and 3, let's try. 2 and this is 2 and 3 is going to be like this 0 0 1 1. And if you do the OR of these two, you are going to get something like this 3 only. So no, with this answer is not possible. So answer of 2 value is not going to be 2. Let's try 3 and 4. 3 you write it like this and 4 you write it like this. Now what you are getting? You're getting 1 1 1. That is, this bit value is 1, this is 2, this is 4, this is 8. So you're getting here 4 5 6 7. You're getting 7 here. No, we need 5. So with 3 or 4 answer is not possible. Now let's see with 4 or 5 answer is possible. So 4 you write it like this and 5 you write it like this. This is 1 2 4 8. This bit value is 16 and 5 you write it like this. So if you do the OR of these two, you are getting 5 now. So with this answer is possible. So here 4 or 5 I'm doing. So that simply means answer of 2 value I'm putting it 4 and answer of 2 plus 1 is equal to 5. So I have to return this 4. So that is why I'm returning 4 here. Clear this part? So for I is equal to 2, the smallest answer of 2 that satisfies answer of 2 or answer of 2 plus 1 is equal to 5 is 4, because 4 or 4 plus 1 is equal to 5. Same way for 7, you need to put here value 3 and then you have to do the OR with 4. So 3 or 4 is going to give you 7. So you have to return 3 here. That's it. This is what you need to do. So let's try brute force first. Then after brute force, I will show you the optimal approach. So in brute force, what you need to do here. So first thing, in the brute force, we have to return one a result array. So I'm going to create one result array. Let's say int result is equal to new int, and here I'm just going to pass the list size. So that is nothing but nums dot size. So list size I have passed here. Now I have to iterate over all the elements of my list one by one. So int I is equal to 0, I is less than nums dot size, and here I plus plus. So for all this I have to find out answer one by one. So what is going to be my target? So target is going to be, let's say original is going to be nums dot get the element at this particular index. So now I get the element at this particular index. So my output, so let's say my output initially is -1. So if we don't find any particular candidate, so I'm going to return -1, right? Just in case of 2, we are returning -1. Now after that, what I will do, I'm going to run one j loop. Int j is equal to, it is going to start from 1. J is less than, I will say, the original number, original, and j plus plus. Now here simple thing I will check, if j or j plus 1. So if this comes out to be, if this value, if it comes out to be equal to original, original, which two values, this j or j plus 1. So if it comes out to be equal to original, then in that case my candidate is going to be this j value. So I will just update my candidate, to be equal to this j value, and I will break it. I don't need to check. So this is very brute force. And here once this is done, then after that here I will just update the value of result of I to this candidate. So if I don't find any candidate, I will just simply say -1. And here like this you are starting. So j is 1 and 1 or 2 you are checking here. Then I'm not checking 0 or 1 because that is always going to be 1, right? But our original will never be equal to 1. It is starting from 2 always, right? This part. So that is why I'm not writing. If you want, you can start from 0 as well. No issues. If you want, you can start it from 0 as well. All right. And here in the end, once all this is done, you have to return result. So now let's run it and let's see if there are code issues. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And here, what is going to be the time complexity? Time complexity, let's say this loop is running of n time, and let's say this loop is running m time, so of n into m. And here you can start from 0. That is also not a problem. If you want, you can submit it, this one as well. But what I'm saying here, if you see the nums of I value, the values which are inside this, they are always starting from 2. So 0 and 1, if you do, you will always get 1 only if you do the OR. So that's why for simplicity I'm starting from here. No issues. You can start from 0 itself. So this is very basic approach. Clear? Very basic approaches. This is your target and candidate is this. You are iterating over the list, and then you are just doing the OR of consecutive elements and seeing if it is equal to original. So if this is the case, then that is going to become your candidate, and you are breaking it. Why I'm not running it less than equal to original? Because my original number will be crossed then. Clear? So that's why I'm not trying that. So this is what you need to do. Very basic approach, brute force. Now let's see the optimal approach. Now we are going to see the optimal approach. Optimal approach. So in optimal approach, let's say you have number as 11. So 11, how I'm going to write it in binary form? 1 2 4 8. So I'm going to write it like this: 1 8 9 10 and 11, like this. This is how I'm I write the number 11 in binary form. Now here, see, this bit is set, this bit is set, this bit is set. I want my number, my target to be like this, and here I have to write two numbers. I have to write two numbers. So here, if this bit is set or if this bit is set, if any bit set is set, I am always going to get output as 1. Clear this part? If any bit is set, I am always going to get the output equal to 1. Now after that, let's check. Let's say if this and this, if any of these two bit is set, I will always get output as 1. Clear this part? If any of these or both bit is set, I will get the output as 1 here also. Now see this. Here I don't want any bit to set. Here I don't want any bit to set. Clear? So definitely this is going to be 0 and here it's going to be 0 only, because in the OR table you know that 0 0 is going to be 0 and everything else will always result in 1. Right? This part is clear. Now let's see here, what should I try here. Let's see at this particular position, what should I try here. I should try 0, right, because I need some minimum number, and here I should try 1, right, to get the output. Here this I want to be minimized, this I want to be minimized. Clear this part? Now after that, everything else, let's take the same 9 and 10. So for this one I'm taking it 0, and I'm taking it 0 because I need it to be minimized. So here I'm taking it 0, and here I will just take the next number of above 1. So I'm getting, let's say, 10. So if you do this now, you are going to get 1011. Why I'm taking here not 1 only 0? Because I need consecutive numbers. I need consecutive numbers. So 9 is going to be the output. 9 is going to be the output here. Clear? I will show you a few more examples. Let's say you have 7. So 7, how you write? 0 0 0, let's say 0 1 1 1. Here this 1, this is 2, this is 4, this is 8. This is how you write. So now this is the output you need. Clear? Now at this position, let's say this is A and B. So here you have to fill some values. Here you have to fill some values. Here you have to fill some values. So definitely this is 1. So any of both of them set or any one of this set, I will get 1. Here same case, this same case, but here it is going to be 0 only. Both should be 0. Now I need it to be minimized. So what I will do, here I will take 0, here I will take 0, and here I will take both are 1, and here I will take 1 and 0 0, like this. So now if you see 1 2 3 4, so this is nothing but 3, and this is nothing but 4. 1 2, this is, sorry, 4, and this is 8. So you are going to get here 3, and here you are going to get 4. So 3 and or 4 is nothing but it is equal to 7. So whatever the first bit in your actual number, if it is 0 here, then the output that you need to return is going to be, just change this to 0 and everything else same. That's it. Here what you did, your output is nothing but this is the first bit. You are moving from here, then here, then here. This is the first bit that is 0. So your output is going to be this bit, change it to 0 and everything else same. So that's it. This is your output. This is the optimal approach. Let's take few more examples. 11. Let's take 13. 13, how you write in binary form? 1 2 4 8. 13 8, like this you write 13 in binary form. So this is the output that you need. Here A and B, here you need to put some values, here you need to put some values, here you need to put value. Here it is 0, that means simply it is 0 here. Now after that, what you need to do, just change it to 0, the next one, and here since we need 1, I will keep it 1 only, and everything else just keep it same. So this is going to be your output here. 1 2 4 8. So this is nothing but 12, and here 12 13. So 12 and 13, if you do the OR, you're going to get 13. So let's see, 12 is the output. See, so this is what you need to do here in the optimal approach. So this is the code that I'm going to write. How I'm going to write the code? So that is also going to be very simple. This 11 is what I need to find out. So 11, how I'm writing by write 11 in binary form, like this: 1 2 4 8. So first I will check, I will do the AND of this. That's simply because I'm checking these two. So if the result is not equal to 0, if the result of both of them is not equal to 0, if you do the AND of these two, so in AND table, if any one bit is 0, you are going to get output equal to 0. Both are 1, then only you are going to get output as 1. Right? This is your AND table. Now here you are not getting 0 here as of now. So in that case, your answer is going to be that this is your target that you want to achieve. So in the target, you have to subtract, this is, let's say, your bit mask. So in bit mask, I'm checking this first bit set, this bit first. So minus bit mask. So you are going to get 11 minus 1 is equal to 10 as your answer as of now. So if you notice here, 10 or 11, it is going to be equal to 11 only, if you notice. So let's say 0 0, how you write 10 in binary form? 1 2 4 and 8. So you write 10 like this: 1 1 1 0 1 0. And 11, how you write? 1 0 1 1. So see, here you are going to get 1 0 1 1 only, right? But is this 10 the correct answer for this as of now? No, we need to check further. So now what I will do, I will left shift this bit mask by 1. So again, my target is this 1 0 1 1. Now I will update my bit mask left shift by 1. So this one is going to come here, and this. So now simply means I'm checking these two. So if I do the AND of these two, I'm going to get again value which is not equal to 1. It is not equal to 1. So now my new answer is going to be the target, which is 11 minus this. What is this value? This is nothing but 2. So that is nothing but 11 minus 2 is 9. So I will update my answer as 9 as of now. Answer is equal to 9. Now I will prove it. 9, how you write 9 in binary form? You write 9 like this: 1 2 4 8. And 10, 10, how you write? 10, you write it like this, right? So now if you notice here, if you do the OR of this, you're going to get 11 only. So with 9 and 10, answer is possible. Here you are checking 10 and 11, 10 or 11. With 9 or 11, 9 or 10, 9 or 10 answer is possible, 10 or 11 also answer is possible. Now I have to check further, because maybe before that there may be some other answer possible. I mean, we have to return minimized. So now next time what I will do, I will again move one left shift. So my target is going to be 1011. Now next time my 1 is going to move here. So again I will check. So this time if I do the AND, so output is equal to 0. So now I have to stop it here, right? And my result is going to be this final answer, the last time that I have found. So this is very optimal approach. This is what we need to do. So we are just iterating over this in the logarithmic time, right? So for this one, time complexity is going to be not n into m. It is going to be very less, because I'm just checking these bits. So whatever the first unset bit, after that I will just change it to 0, and that is going to be my output. That's it. This is what I'm doing. So let's write the code for this optimal approach. So again, here what you need to do, this same thing, right? And you have to run one loop, and here let's say this is your target, int target is this, let's say, and here answer candidate, or you can say answer is equal to -1, and here you say int bitmask is equal to 1. So starts from the least significant, position, least significant bit, you can say. And here this is default if impossible, let's say like this. Now after that you don't have to run this loop, so we have to try removing trailing 1 bits. So what you need to do here, you have to run one while loop, while your here inside this you have to write target and bit mask, you have to do. So if it is not equal to 0, then in that case I told you that your answer is going to be target minus bit mask. So you have to turn off this bit, and your bit mask is going to be less than, you have to do the left shift. So it is going to be equal, new bit mask is nothing but bit mask left shift by 1. So move to, that simply means we are moving to the next bit, move to next bit, and this result is going to be your answer. So here your while loop ends here, just remove it, extra one, and here this is how you are going to update your result of I equal to answer, and here you have to simply return the result. That's it. Now let's run it and see. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And what is going to be time complexity this time? It is going to be of n into log of max of num's value, logarithmic. It's not n into m this time. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Until the next video. Thank you. Bye bye.